In 4.2f, G, and H, I'm going to describe how to avoid the placebo effect in an experiment, explain the meaning and purpose of blinding in an experiment, and explain the context of statistically significant and what that means. So first, the placebo effect. This is the response to a dummy treatment. It's like if you give someone some aspirin. Maybe one group actually has some aspirin that they take, but a second group has a sugar pill that they think is an aspirin, and we want to see if that influences their response. So here's a good example of the placebo effect. A young child fell down and hurt his knee. He came crying to his mommy, stating that he hurt his knee. The mommy replied, "Let me kiss it and you will feel better." The child responded, "Thanks, mommy, I am all better. Can I go back and play now?" This right here definitely has the placebo effect. The actual placebo in this case was the mother's kiss. So that would be the treatment. It was not an active treatment, it was just a kiss in that case. And the placebo effect, what it had is that makes the kid feels better. So the effect is that the child felt better. The actual placebo itself was the kiss. Here's a nice real-life example of a placebo effect in an experiment. In a study reported by the New York Times back in 2008 about bringing relief, researchers discovered that placebos have a stronger effect when they are perceived to be more expensive. The study had volunteers rate the pain of an electric shock before and after a new medication. However, half of the subjects were told the medication they were taking cost $2.50 per dose, while the other half were told the medicine only cost 10 cents per dose. Both medications were placebos, neither were active. 61% of the cheap placebo users said they had pain relief, while 85% of the expensive placebo users had pain relief. None of them should have actually had pain relief. They were placebos. Interesting. The researchers suggested that people are accustomed to paying more for better medications, which may account for the difference in their response. As with any placebo, it's all about the expectations of the subjects. So here it's clear the placebo effect actually happened in both medications. You just have to be cognizant of that the placebo effect can take place within your experiment. Now, in an experiment, you could also do what's called a double-blind experiment. A double-blind experiment is when neither the subject nor those who interact with them and measure the response variable know which treatment is actually being given to a subject. So for example, again, maybe we're testing out an aspirin treatment. We have the real aspirin and we have a sugar pill. The person, maybe the nurse in this case, administering the medication, doesn't know which medication she's giving you, the subject, and you don't know either. You're both blind about it, so it's double blind. On the flip side, single blind, this is when it could be that the individuals who are interacting with the actual subjects and are measuring that response are actually unaware of which treatment is being received. So in this case, the people giving the medicine have no idea which one is being given, but you as the subject, you might. Or it could be the other way around, where the subjects might be unaware of which treatment they are receiving, but the people interacting with them and measuring the response do know. This second one, the latter half, is going to be more common, where maybe the nurse administering the medicine knows which one it is, but the subject does not know. You're going to see that happen more often. The other thing we need to talk about is inference for experiments, and if something is considered statistically significant. What statistically significant means is that an observed effect is so large that it would rarely occur by itself. Basically, this just means the observation that took place, it's so rare that it would happen and occur by itself that it could be statistically significant because it happened when we weren't expecting it. Now, let's talk about this activity here to help us investigate and set up if something is considered statistically significant. David Strayer here and his colleagues at the University of Utah wanted to see if talking on a cell phone while driving was more distracting than if you were talking to a passenger while you're driving. So what they did is they used 48 students that are undergrads, and they put them into half of the students were in a simulator where they were talking on a cell phone. The other half were in a simulator when they were talking to a passenger. The response variable that was measured in this case is whether that they stopped at the rest area that was specified before the simulation. So what they did is they wanted to know if the results were statistically significant. Here's the results that they had. So we're going to see the 24 students that were on the cell phone simulator, the 24 that had the passenger in the simulator. If you're on the cell phone, they exited and stopped at the rest area 12 times, and the other 12 they didn't. For the passengers, they stopped 21 times, the other 3 they didn't. One might conclude when you look at this that you're less distracted with a passenger than you are with your cell phone. But the question is are the results really statistically significant? So to figure this out, what we need to do is to see, would it happen by chance? How random is it that we would have these results? Now, the first question I want to ask, is this considered a categorical or quantitative variable in terms of this? The response was yes or no, so keep in mind this is considered a categorical variable. The responses themselves can be quantified in terms of proportions, and that's how we're going to look at it. So they had to simulate it, and what they did to do their simulation is the first thing is they took 48 cards from a deck to simulate the actual people. And they went through and they realized that when you look at all of the groups, we had a total of 33 that stopped and 15 that didn't stop. So they defined 33 of them to be the stopping and 15 didn't stopping of the cards. So what they did to actually simulate who the people who didn't stop, what they look like, these 15 cards in the deck of 48, they defined that the Jack, King, Queen, and Aces would be the 15 cards. Well, there's 4 of each of these. That's 16 cards, so they removed one of the aces. So these guys right here, if they showed up, would mean that you didn't stop. They then use the numerical face cards, and they remove some to represent 33 of those. So in their deck, anytime you got a face card that's going to show up, it means you didn't stop. Any numbers, the 2 through 10 that show up, means you did stop. So to simulate it, they're going to shuffle the pile at the deck, and they're going to put it in 2 piles, one of 24 cards and the other of the other 24. The first pile is going to represent the cell phone group, and then the second pile is going to represent if you had a passenger in your car. So they made one pile here of 24 cards. They made another pile here of 24 cards. Then what they did is went into this deck of 24 cards and counted how many of them failed to stop at the rest stop, which was identified again by the Jack, King, Queen, or Ace showing up. And they also did it for the pile that reflects if you had a passenger in your car. They then went into a table and they wanted you to do this trial 10 times, recording how many people did not stop at the rest area. So after doing that, what they did is they recorded in this dot plot down here the number of times that people did not stop at the rest area just for the cell phone group. So each dot here represents one simulation, and these were the results. Now, if being on the cell phone doesn't distract you, out of a group of 24, you should see maybe a split of 12 and 12, that yes, you stopped or no, you didn't stop. So the question here of all the trials that we see, how likely is it that there were more or 12 or more times when the people did not stop? If you look at this, 12 or more times that the people did not stop of all our scenarios only happened once. So how likely is it that if you're being distracted with your cell phone that you're not going to actually stop on here? Well, the simulation shows it's rarely going to happen. But when you look at what happened in our real life example, there were far more times where people did not stop. So what conclusions can you make from this? In our case, one time we only did 12 or more people fail to stop when using the cell phone. Since the result of 12 or more is so unlikely to happen, by just chance alone, the result of the study is considered statistically significant. That is, it's very rare for it to happen by chance alone, but in our case it happened a lot, so it is significant.